Pluto is a dwarf planet with remarkable secrets. From Earth, Pluto is too far away to be viewed with the unaided eye. The Sun would only seem like an extremely bright star from Pluto's surface. Despite prior pictures indicating activity on Pluto, many still thought the icy world was lifeless due to its average temperature of -400 degrees Fahrenheit. Things changed when the New Horizons mission from NASA arrived and shed new light on this mysterious faraway planet. In addition to illuminating the neighbouring moons Charon, Nix, and Hydra, the flyby also revealed a plethora of facts regarding the frozen world itself, its young surface, enormous nitrogen glacier, and brilliant blue atmosphere. However, what the durable device finds next surprises scientists. What are the most surprising things discovered by the Deep Space Instrument on Pluto? What hidden mysteries does this region of the solar system attempt to hide from us? Join us as we explore the most recent startling Plutonian discovery. In 1905, American astronomer Percival Lowell noticed unusual discrepancies between Neptune and Uranus's orbits, which led him to propose the existence of Pluto. Lowell reasoned that these ice giants' orbits must be off because of another object's gravitational pull. Unfortunately, Lowell passed away 15 years before the mysterious planet he had predicted would be found was actually discovered in 1915. After years of speculation by Lowell and others, Clyde Tombaugh of the Lowell Observatory finally found Pluto in 1930. Pluto was named after the Roman deity of the underworld, a suggestion made by 11-year-old Venetia Burney of Oxford, England, to her grandpa. The name was subsequently passed on to Lowell Observatory by her grandfather. Percival Lowell, whose initials are Pluto's first two letters, is also honoured by the name. We had long believed that Pluto was the only planet in the Kuiper Belt. However, the number of objects similar to Pluto increased as astronomers understood more and more about the Kuiper Belt, which is similar to the asteroid belt between Mars and Jupiter, but is far larger. In certain aspects, Pluto is more similar to the other planets than they are. With the discovery of so many new bodies, astronomers had to refine our definition of the word planet and assign Pluto to the appropriate group. The International Astronomical Union's astronomers defined a planet according to 3 rules. It has to circle the Sun, be heavy enough to be nearly spherical, and be gravitationally dominant. That is, it has to have cleared its orbit of any other objects with masses comparable to its own. Pluto meets 2 of these requirements, but not the 3rd. Pluto's size is about halved by Charon, one of its own moons. So rather than being the underdog of the planet group, Pluto is now the king of the dwarf planet group. In any case, the historic encounter between NASA's New Horizons mission and Pluto more than 8 years ago is still yielding scientific results. On July 14, 2015, the spacecraft New Horizons flew within 7,800 miles of Pluto's icy surface, providing the first close-up views of the dwarf planet ever seen by humans. New results demonstrate that the mission crew is still uncovering fascinating discoveries as they analyze the data dump collected by New Horizons during the flyby. Scientists know that Pluto, like Earth, tipped over at some point in its history, but they still don't know much about Pluto's orientation before the flip or the extent to which it reoriented itself. To better understand this occurrence, scientists are analysing data from New Horizons to learn more about Pluto's geologic history. Researchers now believe that Sputnik Planitia, a 620-mile-wide basin that comprises half of Pluto's famous heart-shaped feature, is what caused the planet to flip. It was already understood by researchers that the nitrogen ice-filled Sputnik satellite had a significant impact on the surface realignment of the dwarf planet. From there, they are attempting to follow the trajectory of Pluto's flip using photos that New Horizons sent back from the 2015 encounter. They discovered vast valleys and parallel mountain ranges that they believed to be part of a global tectonic system as a result. These features stretch from Pluto's North Pole to a distance of more than 116 miles. All of the landscape that scientists observe today is not where it was originally found, though, as evidenced by Pluto's historical orientation changes. Information gathered by New Horizons is shedding light on Pluto's more modern characteristics, as well as its more ancient regions. Prior to this, the spacecraft had detected enormous methane deposits, some of which were as tall as buildings on Earth, in the vicinity of Pluto's equator. According to new data, which scientists have just announced, these knife-like formations continue all the way to Pluto's far side, beyond what the New Horizons spacecraft could glimpse during its visit in 2015. The finding of these features emphasizes the complexity, dynamic nature, and diversity of planetary surfaces like Pluto's, while also furthering our understanding of mechanisms that shape Pluto and other frozen planets in our solar system. These pillars, which are only a few feet long and composed of water ice, are known as penitentes on Earth. On Pluto, however, these features extend hundreds of feet above the surface and are mostly found at the highest peaks. Methane at these altitudes freezes out of Pluto's thin atmosphere during cold seasons and re-evaporates into gas during warmer periods. The researchers behind the most recent study examined how light reflected from surfaces varies with viewing angle using photos taken with New Horizons Long-Range Reconnaissance Imager, LORRI. Because the surfaces were rougher than the typical surface roughness of Pluto, they were able to find similar methane absorption structures on the far side of the planet. These bladed terrains are probably among Pluto's most prevalent formations. However, on January 1st, 2019, New Horizons passed by Arrokoth, a tiny object in the Kuiper Belt that resembles a partially crushed snowman. At 4 billion miles from Earth, it was the farthest object that a spacecraft had ever traveled to explore. As a result of its distance from the Sun, which maintains a deep freeze, it is also the most primitive. Arrokoth is the soft merging of two objects that were in mutual orbit. The biggest of the two lobes, Waynu, is composed of 12 boulders gathered around a larger slab. The results demonstrate that Waynu did not develop as a whole, but rather from fragments of rock that were already present in the solar system's outer regions. This is unexpected, and a new component in the puzzle of how planetesimals, or the constituents of planets, such as Arrokoth and other objects in the Kuiper Belt, come together. A huge donut-shaped area at the edge of the solar system was formed early in its existence by millions of miles-sized frozen particles. Waynu is elongated because just a small portion of these tiny things combined to make it, and they did not do so quickly. Objects that combine quickly give away material due to their spin, generating circular bodies. Scientists calculate that the rocks would have been moving at less than 1 meter per second when they coalesced, because they have maintained their shape even after combining. Previous studies revealed that Waynu interacted tidally with the smaller of the two objects, causing them to discharge material and lose some angular momentum before merging to form the modern Arrokoth. The individual rocks have a similar appearance to Lego pieces and are identical in size, composition, and color. These characteristics all provide crucial information about how Arrokoth formed. At the same time, the dwarf planet's remarkable complexity is being further revealed. A supervolcano that erupted a few million years ago may have been discovered by scientists analyzing data from spacecraft that point to an odd crater close to the heart-shaped Sputnik Planitia. From a cosmic perspective, that may seem like a very long time ago, but in reality it's rather recent. The age of the solar system exceeds 4.5 billion years, just to put it in perspective. However, in a process known as cryovolcanism, the Kaladzi crater appears to have spewed frozen lava onto Pluto's surface in place of the molten rock that erupts from Earth's volcanoes. The process is believed to have forced water from the planet's deep underground ocean onto its surface, altering it over millions of years. It also occurs on the moons of gas giants in our solar system and probably caused other mysterious terrains on Pluto. Since volcanoes need a heat source of some kind to erupt, Pluto's current activity indicates that there may be more heat in the dwarf planet's interior than previously believed. The Kaladzi crater initially resembled those caused by meteorite impacts, but it didn't seem to have the center peak that these geological occurrences are known for. It also appeared somewhat elongated, in line with motions brought about by internal tectonic forces on Pluto. The predominant presence of water ice surrounding the crater serves as a tip-off that Kaladzi is different from the majority of Pluto's surface, which is covered in nitrogen and methane ice. The methane ice that blankets most of the planet's surface is easily distinguished from the water ice. As it rounds the Sun, Pluto experiences tremendous climatic fluctuations due to its axis tilt of a sharp 120 degrees, which causes it to spin practically on its side. Consequently, in the atmosphere of the dwarf planet, methane ice sublimates into a haze of hydrocarbons, some of which fall as snow and cover the planet's surface. Scientists believe that this layer of methane ice on Pluto must have reached as thick as 46 feet during its 4.6 billion year existence. The spectral signature of the water ice that we see would be obscured by even a centimeter or two of this biological haze. It would have taken only 3 million years for such a layer to have evolved. Because of this, paleontologists determined that Kaladzi was alive less than a millennium ago. To this day, Pluto's cryovolcanic activity remains a mystery to scientists. Since the dwarf planet is so tiny, it would have dissipated all the heat it had when it formed a very long time ago. Previous studies indicated that there might not be enough radioactive elements to power up Pluto, but it is possible that the dwarf planet did possess some in its core, which would explain why it generated heat as it decayed. However, something seems to be preventing Pluto's subterranean water from freezing, regardless of the source of heat. If we eventually do find life on Pluto, this would undoubtedly revolutionize science. Don't you think so? Let us know what you think in the comment section below. Don't forget to subscribe to our channel and turn on the notifications for more videos. See you soon.